Good morning, students. For the last class, we had seen concurrent force and Lamarck's theorem, right? So here our next topic is applications of Lamarck's theorem. That is example number 3.14 problem. Okay. So here what they given? A baby is playing in a swing which is hanging with the help of two identical chains is at rest. Identify the forces acting on the baby and apply Lamarck's theorem and find out the tension acting on the chain. Okay, so here is a baby and what is that? And he is playing in a swing. Okay, so initially the swing which is at rest only, and we have to identify what are the forces acting on the baby and find out the tension with the help of what? Lamarck's theorem, right? So this is a free body diagram. Just consider this a baby should be considered what is it here? Point mass. So this is a baby. So in which these are the two chains here, which means tension force can be acting along the chain here, right? So for the downward mg force, that is gravitational forces acting here. Okay, so here they are asked to find out what are the forces acting on the baby, right? So in which there are three forces acting on the baby here. Okay, the first one is downward gravitational force, that is mg force here, and second one is tension along two strings. So in which two strings, two tension forces are acting here. So totally what? Three forces are acting on the baby. Okay, and there is a diagram, and there is a rigid support here, and there is a baby, and along the chain the tension forces acting here. In downward what? mg forces acting. Okay, so see here, this tension can be resolved into two components. One is the horizontal component, another one is what is that? Vertical component, which means we have to find the tension here, right? So horizontal component is nothing but what is it here? T sin theta, T sin theta. Okay, and the vertical component is acting along only in the upward direction. So it is what? 2t cos theta. Okay, so horizontal component is sin theta, vertical component is what is it here? Cos theta. Okay, so in horizontal it is T sin theta, and this is also what is that? T sin theta. In the vertical side it is of only one side, so it is 2t cos theta here. Okay, so how will you find out tension here? So by using Lamarck's theorem, we know the formula. What is that? The magnitude of each force is directly proportional to the sine of the angle between other two forces, right? So here, this tension force, it is nothing but F1 force there. This tension force is directly proportional to sine of this angle, that is alpha here. And this tension force is directly proportional to sine of this angle, that is beta here. Okay, and this mg force is directly proportional to this, what is that? Here gamma force, angle gamma here. Okay, so we have to find out the tension now. Okay, how will you find out it? Listen, so by Lamarck's theorem, we know the formula it is, what is that? Modulus of f1 vector by sin alpha equal to modulus of f2 vector by sin beta equal to modulus of f3 vector by sin gamma equal to what is that? Constant here. Okay, so this f1 is nothing but what is that? That is tension force, that is T by sin alpha. Alpha is nothing but what? Angle here. How will you find out the angle? So we want to know what is that? This angle, right? So we know it, and this is angle, right? That is of what? 180 degree. So this angle is fully 180, but here it makes an angle theta, and here also it makes an angle, what is that? Theta here. And remaining part only is what? Alpha. So, and this fully is 180 degree, and this part is other, what is that? 180 minus of this theta. That is what is it here? Alpha. So sine of 180 minus theta equal to modulus of f2 vector. That is nothing but this side. So that is also tension T here. So T by sine of beta. So what is angle beta? And this fully part is 180. And here it makes angle theta here. The remaining part is what is it here? 180 minus theta here. So sine of 180 minus theta equal to F3 force. What is F3 force here? mg force. Okay. So mg by sine gamma. So sine of gamma this angle. So here an angle theta here. Here an angle theta here. So what is it totally? 2 theta. So sine of 2 theta. Okay. So what is sine of 180 minus theta? By trigonometric connection we know it. Sine of 180 minus theta is what is that? Sine theta. Okay. And here sine 2 theta is here. What is the formula for sine of 2 theta? cos theta. Okay, so we just substitute here. So T by sin theta equal to mg by 2 sin theta cos theta. Okay, so see here also T by sin theta, that is equal to what? T by sin theta. So we can take any one of the term here. Okay, so both are equal here. So T by sin theta equal to mg by 2 sin theta cos theta. So 1 sin theta gets cancelled here. Okay, so remaining tension T could be equal to mg by 2 cos theta. This is a tension equation. Okay, T equal to mg by 2 cos theta. Okay, suppose the angle theta equal to 0 degree, which means what? What is cos 0? Cos 0 becomes what? 1. So we get T equal to mg by 2. So which means what? Tension is exactly half of the gravitational force here, which means the strings are hanging vertical here. Okay, that's it. So this is the tension equation. So T equal to mg by 2 cos theta. Okay. The next topic is law of conservation of total linear momentum. Okay. So in general for mechanics, there are three conservation laws. The one is the conservation of total energy, and second one is conservation of total linear momentum, and third one is conservation of angular momentum. Okay, so here our topic is what? Conservation of total linear momentum, right? So how will you conserve the total linear momentum? Okay, so here we are going to combine the Newton's second law and third law, so we can able to derive the law of conservation of linear momentum. Okay, so we learned already in Newton's second law, we know the formula, right? What is that? By law is what? The force is equal to rate of change of momentum, right? So this F vector equal to dt vector by what? dt. So force is equal to rate of change of momentum. Okay. So what is this third law? For every action there is an equivalent opposite reaction. Okay. So the formula we know it. F12 vector equal to minus of what? F21 vector. Okay. So here we just consider any two particles. Okay. So one is a particle 1 and one is what is that? Particle 2. Okay. So these two particles are made to interact with each other. Okay. So this is a particle, this is a particle, right? So these two particles are made to interact with each other. So what will happen? This particle can exert a force on this particle, and this particle will exert a force on what is that? This particle. Yes or no? Yes. So that is that what? The force F12 vector equal to dt1 vector by what is that? dt. Which means the particle 1 will exert a force on the particle 2, will experience what is that? F21 force. Right? That is F21 force equal to dp2 what is that? By dt. Okay. And F12 equal to dp1 vector by what is that? dt here. Okay. So p1 is nothing but momentum of the particle 1. Okay. And p2 is nothing but momentum of the particle 2. Okay. So initially I said that we have to combine Newton's second law and third law. This is nothing but Newton's second law formula, and this is what is that? Newton's third law. So we got the value for what is F12 and what is F21 here. So we just compare it here. Okay. So F12 is nothing but dp1 by dt, right? So dp1 vector by dt equal to minus of F21. So minus of dp2 vector by dt. Okay. So when this term come to this side, it becomes what is it here? Positive. Okay. So dp1 vector by dt plus dp2 vector by dt equal to 0. Okay. So here d by dt is common in both terms. So I take it outside. So d by dt of p1 vector plus p2 vector equal to 0. Okay. So we know it. What? d by dt of p1 vector plus p2 vector is 0 means we know it. p1 plus p2 equal to what is that? Constant. Right? So p1 vector plus p2 vector is always what is that? Constant vector here. Okay. That is p1 plus p2 is nothing but when we add these two terms we can get what? Total momentum here. Okay. So p total vector equal to p1 vector plus p2 vector, which means what is that? The total linear momentum of the system is remains what? Always a constant vector. Okay. So by the statement we should say what is that. So here there is a statement for law of conservation of total linear momentum. So what is the statement here? If there are no external force acting on the system, then the total linear momentum of the system is always what is that? Constant vector here. So how it is? So see, you know the formula F equal to dp by dt. Okay, when F is set to be 0, which means dp by dt equal to what is that? 0. Then P is what is that? Constant. That is nothing but linear momentum is constant when the force is set to be 0. Right? So that is a statement here. If there are no force acting on the, which means no external force acting on the system, then the total linear momentum of the system is always what? Constant vector here. Okay. So you should ask one question. But here we put what? F12 force and F21 force. Right? So these two can be acting. So in which we can derive that momentum is what is that? Constant here. But you see, here this F12 and F21, these two forces are internal forces because these two forces acting between particles here, right? But there is no external force acting on the system. Okay, so that's what the total linear momentum is remains what? Constant here. Okay, so this is nothing but law of conservation of linear momentum. So the momentum is conserved here. When no external force acting on it, then the total momentum is constant. Okay. And one more thing, the main important thing is when P1 and P2, when separate term for linear momentum, P1 and P2 is an individual term, it can make it vary. But P1 vector plus P2 vector is always what? Constant vector only. Okay. But individually it can be made to vary. But when we add these two, we can get the total linear momentum is always what? Constant vector only. Okay. And what is the meaning of the conservation of momentum? Law of conservation of momentum. What is the main meaning here? So you should see that this law of conservation of linear momentum, it is a vector law. Okay. And we know already that Newton's law also what is that? I said it is a vector law. Here also what? Conservation of linear momentum, it is what is that? It is a vector laws. Which means it has both magnitude and also direction of the linear momentum. It is always what? Constant only. Okay. And next one is to analyze the motion of particle. When we just consider particle, the particle to be in motion. When we use to analyze what is the motion of the particle, we can use what? Newton's second law generally. But here what? We can use either Newton's second law and or what is that? Law of conservation of linear momentum. Okay. But the thing is what? By using Newton's second law, we need the force. Yes. Because F equal to ma, the force can be required. Yes. But by using law of conservation of linear momentum, the force does not require. Right? Because there is no external force, then the momentum can be conserved. Then we can able to analyze what is the motion of the object by using what? Law of conservation of linear momentum. Okay. So the next one is the example of law of conservation of linear momentum. Okay. So what is the example? The best example is firing of a gun. Okay. You just consider what is that? A gun and the bullet. Okay. And these two would make to what? Consider as a system here. Okay. Which one? Gun plus bullet is said to be what? System. And we know before firing, initially both gun and bullet is said to be what is that? Rest position only. Okay. So initially the system, that is nothing but gun and bullet is said to be what is that? It is at rest. Okay. Let this P1 is the momentum of the bullet and P2 is the momentum of what is that? Gun. So before firing means both bullet and gun is said to be what is that? Rest position. Right. So rest means what is that? P1 vector plus P2 vector equal to 0. It is not firing. So before firing, it is at rest position. Okay. So when the gun is made to fire, what will happen? It is made to fire means what will happen? Automatically, the bullet can move forward. The force can be exerting there. The bullet can go out. It moves what? P1 dash, and P2 also made to change, that is what? P2 dash. Okay, once you made to fire, the bullet can move forward and the gun can move, what is that? Backward. So which means to conserve the law of conservation of momentum, so P1 dash plus P2 dash could be equal to 0. So according to the law, this could be equal to what is that? 0. So when the term can be used to this side, it becomes what? P1 dash could be equal to minus of P2 dash vector, right? Which means after firing, the momentum of the bullet can be exactly equal and acting opposite to the momentum of the bullet here. Okay, the term is nothing but recoil momentum. What is that? Recoil momentum here. Okay, which means here before firing this could be equal to 0. After firing also, what is that? This total momentum could be equal to 0. So this is known as law of conservation of linear momentum. Okay. The next topic is impulse. Okay. So what do you mean by impulse? So impulse is nothing but if a very large force acts on an object for a very short duration. Which means if a large force is acting on the body in a short interval of time, then the force is called as nothing but impulsive force or else what? Impulse. Okay. So if you consider if an object, if the force F is acting on the body in a short time, that is del T time, so we can arrive this equation from Newton's second law. Okay, so from Newton's second law we know force is equal to what? Rate of change of momentum. That is F would be equal to dP by dt. Okay, so by doing cross multiplication, we get what? F into dt equal to dP. Okay, so next what we have to do? We have to integrate this. So by doing integration, so integral of dP to the limit is what is that? Here momentum is changing here. Okay, so the limit is initial momentum to final momentum. That is Pi to Pf equal to integral of F into dt. Here time can be carried here. So Ti to Pf, initial time to final time. Okay, so when we integrate dt, we can get what? Only P, right? So the limit is Pi to Pf here. So that is equal to, so F is constant and taken outside. When you integrate dt, we can get what? T. So T to the limit Pi to Tf. Okay, what is the next step here? We have to do what? Upper limit minus lower limit. Okay, so Pf minus Pi equal to F into Tf minus Pi here. That is it. Okay, so final momentum minus of what? Initial momentum. What is final momentum? What is initial momentum? That is nothing but change in momentum. Okay, the change in momentum is nothing but what? Del P equal to F into final time minus initial time. That is what is that? Change in small interval of time, right? That is nothing but what? Del P here. So del P equal to F into del T, right? So for the constant force with respect to time here, that would be equal to what is that? Change in momentum. Okay, so this equation is called as impulse momentum equation. Why this impulse momentum equation? Because del P is a momentum here. So for impulse I say, what is that? The force can act on when a large force is act on a short interval of time. So force into time is nothing but what? Impulse. So force into time is called as what? Impulse. Okay, so del P equal to F into del T is called as impulse momentum equation. Okay, so del P equal to F into del T is nothing but J. So J is a symbol for impulse. So force into time is called as what? Impulse. That is nothing but J. Okay, so this impulse is a vector quantity and the unit is what is that? Newton's second. Because for force it is Newton, for time it is what? Second. So the unit of impulse is Newton second. Okay, so listen. So for a constant force, for it is constant. Okay, the expression is F into del T equal to what is that? J. Like this F into del T equal to J. Because del P equal to what is it here? J. So F into del T equal to J. Okay, so for average force, which means force is said to be constant, we have to apply this condition. J equal to F into del T. For example, the force can be made to bearing. That is for average force. Like for average del T. This is a average force expression. So by including this momentum impulse equation, it can be changed as what is that? J equal to F average into del T. Because impulse equal to what is that? Force into time. So for average force means J equal to F average into what is that? Del T here. Okay. So this is nothing but the graphical representation of constant force impulse and what is that? Variable force impulse. Okay. So constant force impulse means it should be like this. For x-axis it is nothing but time. For y it is what is that? Force. So force is said to be constant means we can get a curve like this. It is like the exact perfect square here. Okay. So this is the area under that. What is that? Impulse region here. That is J equal to F into del T. That is what I said. For a constant force means J equal to F into what? Del T. Okay. So in between center part is nothing but average force. Okay. So for a variable force impulse means the graph should be like this. The same thing for axis time. For y it is what is that? Force here. So the curve could be like this. It is not constant. The force could be not what is it here? It's not constant. So we can get a curve like this. Okay. This is the area under the region for the impulse equation. That is J equal to integral of F into dt to the limit what is that? Ti to Tf here. Because here force is said to be constant, so J equal to F into del T. Here force is variable here. So we have to use this expression, which means within the limit the force is variable, right? So J equal to the limit of Ti to Tf, F into what is that? dt. Okay, so this is nothing but impulse and constant force impulse and variable force impulse. Okay, so the next one is example 3.16 problem. Okay, so what they given in the problem? An object of mass 10 kg moving with a speed of 15 meter per second and hits the wall and comes to rest within 0.03 second and 10 second. Calculate impulse and average force for both cases. Okay, so what they given actually? So initially an object put down it is 10 kg. So it is moving with a speed. So initially the object is moving, right? The speed that is nothing but velocity. It is 15 meter per second. And finally it can hit the wall and comes to rest. Okay. So initially it is moving and finally what? It comes to rest position. The time of 0.03 second and what is that? 10 second. So we have to calculate what is the impulse and what is the average force for both cases. Okay. So mass is given 10 kg and velocity is given what is that? 15 meter per second. Okay. So initial momentum. What is the initial momentum? Because impulse equal to formula impulse to P equal to what is the J equal to del P. Right. So del P means we have to know what is initial momentum and what is final momentum. So initial momentum is Pi equal to M into V. This is a formula for momentum. M into V. So initially it is moving the object. So mass is 10 kg and velocity is what? 15. So when we multiply these, we can get what? 150 kg ms per minus 1. Okay. And the final momentum is Pf equal to what? 0. Why it is 0? Because initially the object is moving, so it has initial momentum. And finally it comes to rest, so it becomes rest position, no? So momentum could be what is that? 0 here. Okay. So what is del P? So del P means what is that? So what is the difference between the Pi and Pf? So 150 minus 0 equal to 150 kg ms power minus 1. Okay. So we have to calculate the impulse for both cases and average force for both cases. For both cases, the impulse, the formula we know what is that? J equal to del P. Okay. So impulse is same here because for a constant, impulse is what? Same here. So J equal to del P. So del P what we get here? 150 kg ms power minus 1. And the second case also, what is it? For 10 second, that is also what is the same only because J equal to del P. So del P equal to 150 kg ms power minus 1. Okay. For the average force, this force can be varying here. Okay. So for the average force formula, F average equal to del P by what is that? Del T. So what is del P? We got 150 here and del T is the first case is 0.03 seconds. So 0.03 by doing cancellation. Okay. So from this we have to note it down that what is that? Here impulse is same for both cases, but the average force is what is that? Different here. Okay, because impulse J equal to del P, that is for constant force it is same. Okay, for average force it is different. Okay, that's it.